Today's lesson is a combination of Chapter 4, Lesson 2 and Chapter 4, Lesson 3, comparing and ordering percents, fractions, and decimals. Now, I'm hoping a lot of this is going to be reviewed. If it's not, we may have to go back and do this a little bit slower. But hopefully you've seen all of this before. Some of it we've already covered in class. In order to compare fractions and percents, or fractions and decimals and percents, the simple trick is just to make them all the same thing, right? Either make them all fractions, or make them all decimals, or make them all percents. And you're going to have to decide which one is easiest for you. There's no one that's better than the other. If you want to make them all into decimals, that's fine. If you want to make them all into fractions, that's fine too. If you want to make them all into percents, that's fine as well. It's up to you. For example, let's take a look at this problem right here. We've got two values, 1/5 and 30%. Now, I'm going to show you a few different ways we could solve this problem. One way would be to turn both of these numbers into percents. So, to turn 1/5 into a percent, we really want it to be out of 100. We want something out of 100. That's what a percent is, part out of 100. So, to make 1/5 into some part out of 100, we see that we had to multiply our denominator by 20. So we multiply our numerator by 20, and we get 20 parts out of 100. Now you can probably already see where this is going to go. 20 out of 100 would be 20%. If we compare that to 30%, obviously 30% is greater than 20%. 30 is more than 20. So we write our greater than sign that way. Remember, in case you're having a hard time remembering, that with greater than signs and less than signs, you always want the open end to point towards the greater value. Right? It's open wider. It's going towards the greater value. Some people remember the crocodile mouth, right? The hungry crocodile always wants to eat the biggest thing. So 30% is greater than 20%, 20% is less than 30%. Now let's take a look at another way to solve the exact same problem. This time, instead of turning them both into percents, I'm going to turn them both into fractions, right? 1/5 is already a fraction, so we're going to turn 30% into a fraction. Remember that 30% is the same thing as 30 out of 100. Now, to compare these two fractions, they need to have the same denominator. So I can either change them and find the least common denominator of 1/5 and 30 hundredths, or I can take a look and see that 30 hundredths can be put into simplest form as 3/10. Right? We're going to divide them both by 10, 3/10. Well, now it's easy. 1/5, if I want to give that a denominator of 10, we're just going to multiply them both by 2. So we get 2/10 as compared to 3/10. Obviously, 3 out of 10 parts is more than 2 out of 10 parts. 3/10 is still greater than 2/10. So 30% is still greater than 1/5, right? The same result we got last time. This is just a different way of solving this problem. Finally, the other way you could solve this is that we could turn these both into decimals. Sometimes this is actually going to be the easiest way to do it, even though you have to work with both numbers. To turn 1/5 into a decimal, we have two choices, right? We can either do what we learned a couple chapters back, where we made our denominator into a 10, and then it would be much easier to kind of move from there into a decimal, right? You can see how many tenths it already is. The other way we can do this, of course, is to actually divide. 1 divided by 5. This is what we were doing in our last chapter. We're going to need a couple extra places here. 5 goes into 1 0 times, decimal up. 5 goes into 10 2 times. 2 times 5 is 10. Nothing left there, so we don't need that extra 0. So 1/5 is the same as 2/10. Now 30%, we already know, is the same thing as 30 hundredths. Now again, this is one of those places where I hope you really remember the stuff you were doing in 4th grade, and 5th grade, and 6th grade, because to compare decimals, remember, sometimes kids get confused here. They look and they go, oh, well 30 is far more than 2. But remember that what we're really looking at here That extra 0 on the end doesn't actually add value. You could add an extra 0 here. Remember, we can always add those extra zeros to the end of a decimal. It doesn't make it any larger. When you're comparing decimals, all you want to do is you just start from the left. 0 is the same as 0, 3 is greater than 2. Nothing else matters. Once you've hit that first point where they're not the same, one is greater than the other, none of the other digits matters. It wouldn't matter if one of them was 500 digits long and the other one was only 1 digit long. We hit that first spot where they're not the same, 3 is greater than 2, and we know right away that our right side is greater than our left side. Hopefully that's review. If not, we'll talk a little bit more in class, and hopefully I can help you out. Okay, here's a problem for you to try on your own. I want you to put these numbers in order from least to greatest. You've got 4 numbers up here. I want you to put them in order from least to greatest. That's 25%, 2/3, 4/5, and 37 hundredths. Pause now, and when you hit play, I will show you how to solve this. The answer to this problem is that 25% is less than 37 hundredths, is less than 2/3, is less than 4/5. Let's take a look at how I got that answer, and then we'll talk about how to write your answers down. I turned all of these into decimals. That's the one that works best for me, and it's the one I'm going to sort of recommend for you. But again, go with what works best for you. So 25% we know is 25 parts out of 100, 25 hundredths. 25 hundredths, so I rewrote it here as 25 hundredths. 2/3, I did 2 divided by 3, and I got 0.666. The 6's would have kept going. Remember, that little symbol over the 6 means the 6's would have gone on forever. It means 6 repeated. So 0.66666. And then 4/5, I did the same thing. 4 divided by 5, and I got 8/10. And 37 hundredths is already a decimal, so I didn't have to do anything. Well, now I have numbers that are very easy to compare. Again, when you're comparing decimals, all you have to do is just start from the left and see which is greater. It doesn't matter which is the longest, it doesn't matter which is the prettiest. Only as you're moving from left to right, which one has the greatest integer first. So 0, 0, 0, 0, all the same. 2, 3, 6, 8. Look how easy it is to put those into order. 25% has the 2, 37 hundredths has the 3, 2/3 has the 6, 4/5 has the 8. 2 is less than 3, 3 is less than 6, 6 is less than 8. Nothing else matters. Now, I want you to notice with my answer, I hope you can see it down here, I know it's a little bit low. With my answer, notice that I wrote, first of all, I put them back into the original form of the question, right? We're comparing these 4 values, not these 4 values, even if they're the same. We're comparing these 4 values in purple. So I wrote them that way for my answer. 25% is less than 37 hundredths, is less than 2/3, is less than 4/5. Notice that I still use that less than sign. Notice I'm still using that sign. I don't put commas, I don't put semicolons. Not every teacher is going to do this the same way. This is the way I want you to solve this. 25% is less than 37 hundredths, is less than 2/3, is less than 4/5. If you got that right, great job. If not, look over my work and see if you can understand how I got it.